Everyone, I want to welcome you to today's webinar on the National Cooperative Soil Survey's Soil Characterization Database Current Developments. I'm Sean McVeigh, National Training Coordinator for the Soil Science Division, and I'll be moderating the webinar today. Our presenters are Henry Ferguson, Soil Scientist here at the Center, and Rick Nesser, Computer Programmer here at the National Soil Survey Center as well. Today's webinar is being recorded. You can enter a question using the Q&A tab at the lower left corner of your Adobe Connect screen, and we'll take those at the end. You can also, if you have general comments or questions, you can put those in the chat, and I've just started a chat message there to get people started. Today, you're all listening through your computers. You're in listen-only mode, and so the only way to communicate with us is through the chat or through the Q&A. With that, I'm going to go ahead and turn that over to our first presenter, Henry Ferguson.
Hello, everyone. We had a webinar about 2 years ago, and this webinar is a follow-up to let everybody know what the progress has been since then. At the time, we were copying pedons in NASIS. We had, like, when people submitted laboratory data or pedons for laboratory data, they entered the pedons into NASIS, and the sites and the pedons were being copied. And it was causing some problems because we couldn't track pedons and we couldn't find them. So we tried to implement a system where it was easier to track things and keep the data and the pedons coordinated. So the identifier that actually links the pedons to the laboratory data in NASIS is called the lab pedon number. And as long as people populate that in their pedon, we have a data mining report in NASIS that goes in and finds a unique pedon for each of the laboratory samples in the database. That is a good thing and a bad thing. The good part is it does find a unique pedon. F1 exists, and it links any matching pedons with the same laboratory number together. The bad part is that if people copy pedons to use as test pedons or to play around with, or if they make up laboratory sample numbers and put in that field, if it happens to match an existing laboratory sample number, we end up distributing that data instead of the official data. So as of today, now that we have these data mining reports working, it's really important that folks keep that laboratory sample number field clean. Because that is the field that we key off when we deliver data to the public. So now we actually have a single site for locations in NASIS, and that site is owned by the Soil Data Quality Specialist. And they have the option of asking me to add other individuals to that group, and some of the Soil Data Quality Specialists have done that. But the sites are now owned by the MOs, and any of the changes that are made to those sites are made at the MO level rather than here at the center. Prior to 2012, if you wanted to figure out what location to use for a pedon, that location can be found in up to 13 different places. You have 2 copies of the pedon. When we reduced it to a single site, we're now down to 9 or 8 places where you could find the site. And what we've really tried to do is limit that site or identify the unique location for the site as a standard decimal degrees WGS 84. So that is the single location that we use in our reports for plotting points on a map. A couple years ago, Jason Nemechek added a map to one of our pedon description reports, so when you run the report, you can actually see where that location is on the ground. In March 2010, we published a new version of the Google Fusion map, which shows the location of the laboratory pedons that we have in our database. And since that time, people use that pedon description report and the linking and tools to identify several pedons that were mislocated in NASIS. And this shows in red those locations that were incorrect, and the green locations are the ones that they were moved to. Besides the locations being updated, the system also allows for us to data mine for the latest classification. Even in 2012, we actually just delivered the most current classifications in the pet on description. But as of the new website being released about a month ago, we now have the classification from the MLRA pet on going on the pet on description reports in the laboratory data that we distribute. So how often do we actually update these maps in the databases? It really depends on the number of projects that go through the laboratory. We're hoping that we can start updating this database on a quarterly basis. Up till now, it's been updated about once every 6 months. And what do we update? We have the website, of course. We have the Google Fusion map that you just saw. We produce an access database that we distribute to cooperators that would like to use our data in a bulk form. And we also have been updating new laboratory tables that were added to NASIS for our NASIS users. And how are each of these products different? When we talk about the Laboratory Information Management System, it's sort of a local database here at the center, and it was created around the year 2000, so it doesn't contain any of the data prior to 2000. We have another database called the NCSS Soil Characterization Database, and that database contains information from prior to 2000 and the data that we get from LIMS, or the Laboratory Information Management System. If we run a sample more than one way, that database may include both moist and dry results. It also may include some negative values, depending upon the accuracy of the machines and the precisions of the machines that are taking the values. It can also include, at times, some values that are greater than 100% for things like bulk density or base saturation when it does calculations. All the data in that database is stored in text format, so it can actually include both text and numbers for a particular result. We then take that data and we export it to an Access database, which has other restrictions. So in the Access database, we still allow for multiple rows, moist and dry. We do allow for negative values, but it only has numerical values for fields, so it can only accept numbers. It can't accept things like trace or dashes. When we export that data again to NASIS, we clean it up a little bit more. We actually reduce the amount of the results to a single row per sample. We don't allow any negative values, and we can't allow for any text values because if the result is a number. And most of the percents are restricted to less than 100%. So part of this is due to the history of the database, and that is that the repository or the results database was often used by researchers, and we had this website front end on it that actually had some logic to it that would convert zeros and nulls to, or convert negative values to either nulls or zeros. So once we actually process this data and make it cleaner for the soil scientist to use, how easy is it to use? When you're in NASIS, these are a couple of helpful hints for using that laboratory layer table. If you take that NCSS lab layer table and open it up, it takes about 23 seconds to open an empty table. And you can load small amounts of information into that table, and it takes like less than half a minute. If you load all of the laboratory data into that table, you can still view it in about 3 minutes. But if you don't open the table first and you try to load a lot of data, it can take up to 2 hours, and you still can't look at the table. So it's sort of important that you remember, and this can apply also to your component data and some of the other tables in NASIS, that if you open an empty table first before you load the data, it's a lot easier to work with child tables in NASIS. One way to get around using the tables directly in NASIS or view them directly in NASIS is to connect access to it through an ODBC connection. And there are directions on the web on how to do that. If you actually connect access to NASIS, you can view those same tables almost instantaneously instead of taking hours to open them up. So what's left to do on that original diagram? There's something called an original horizon designation and a current horizon designation. That refers to when you dig the pit. If you have 5 soil scientists, you might have anywhere from 1 to 5 opinions on what horizon designation should be put on that horizon. And then over time, our horizon designation nomenclature has changed. So one goal that I have for this database is that we somehow try to capture the very first horizon designation that somebody decided to put on that horizon and the most current horizon designation that people would like to apply to it today. And the other thing that's happened is over the years, we've changed how we describe soils, and we've changed how we've described where we've started the top depth of the soil. At one time, it was the top of the mineral, and now it's the top of the first organic soil layer that supports life. And so our database has been around for decades, and it contains a mixture of these depths and a mixture of these horizons. And there's an attempt to try to make a little more sense. And one way that we can do that is by using the NCSS lab layer table in NASIS as sort of a staging server, much as we do with our Sergo data, to sort of take the information from all 3 databases, the Laboratory Information Management database, from the repository or NTSS laboratory database, and NASIS, take those and the NASIS pedons, and sort of merge those together and basically data mine the database for the original horizon designation, the most current horizon designation, and the most appropriate depths for each sample based upon post-1995 standards. The only way for that to happen is if we actually populate a table in NASIS called the Pedon Horizon Sample Table, and that table has to match the NCSS Layer Lab table. If we can actually get the same sample number in both those tables, we can then use the queries and reports and data mining tables reports to extract this information. And where is it going to go? This is an example of a description from the web. And notice that the information that's in the green boxes we are already doing. So we've got data mining reports that already extract the latest classifications and the original classification. And it extracts the current location. And the next step is to create reports or somehow come up with original horizon designation, current horizon designation, and standard depths post-1995. There are about 8,000 pedons in the laboratory database that have depths that don't start at the top of the organic layer. Now, the question is, who can actually modify this table? And at this point, I'm the only person in the country that has access to that particular table to update it. If people find errors or would like to get that table updated, and I'm not finding their errors or their changes fast enough, there are 3 reports in NASIS that they can run. They can load their data and run the NCSS Lab Layer Horizon Current Update, the NCSS Lab Layer Horizon Name Original Update, or the NCSS Layer Laboratory Table Depth Update. If they run those reports, it provides me with a file that they can save, and I can run that against the database, and it will update that table in NASIS. I would only run I would only do the update if number one, the field has to run in the first place, and number two, it has to meet the standards, our current standards. So the distribution products I've been discussing so far are, one is the website, which just came out in February 10th, 2015, and it incorporates a join table that allows us to merge the latest classification and location with the laboratory location and classification and present that to the public. We've also updated some of the reports on that particular website. One in particular is the Supplemental Characterization Sheet Tier 2. Buried in the documentation, there's a footnote that says that if we don't have a bulk density that's measured, that our laboratory information management system will apply a default value of 1.45 when doing calculations on this particular sheet. And sometimes 1.45 is appropriate and sometimes it's not. So these footnotes allow us to know by looking at the report as to when this default value was used. So if, for example, a field soil scientist reviews or runs these reports and they find a default value of 1.45 in a footnote for an OI horizon, for example, an organic horizon, they can notify us and we will remove that information. So this is a good QA/QC tool for our database. The next product is a Google Fusion map, and currently this map is what you see is what you get. That's what's in NASIS. So if you find some points that look weird on the map, if you send us, the way to fix that map is to go into NASIS and send the new location to your soil data quality specialist and have them update NASIS. When we run our reports, we'll pick up the new location and the point will move. Once again, the products are updated every 3 to 6 months, so it could take anywhere from 3 to 6 months before you see a change to the map. There's also a complete copy of the Access database, which people used to have to ask for individually when they wanted a copy. Now we have a link on the website. And so you just go to the website, look for the link, and you can download the database. I got a little red X because the file size is incorrect. It's about a 100 megabyte zip file that you download, and it unzips to about 600 megabytes. But that Access database is now available to the general public or anybody that wants to pick it up. Once again, we take that data from the Access database and the National Cooperative Soil Survey Characterization database. We filter it. We apply some rules. Most of the rules we apply are the same rules that are applied to the website when it displays the data in reports. And then we export that to a file which we upload to NASIS. And then there's about 64,000 pedons worth of data in NASIS at this time. Sometimes people ask for the actual pedon descriptions that go with the laboratory database. About once or twice a year, I update an Analysis PC database, which people can get from me if they ask for it. It requires a download of every 10,000 pedons until I build the database up to the 63,000, and then then I can export that and deliver it to whoever wants a copy of the morphological data. Anybody can make an Analysis PC download just by running the report out of Pangea. We also added the analysis tools to Pedon PC that were in Pedon PC Plus. They were added to Pedon PC. So you can also do a download of PET on PC data and evaluate in PET on PC. And the report is once again in that Pangea for that as well. And Dylan and his and group, they've been working with R, and they've got a fetch NASIS query that you can use to extract the laboratory data and analyze it in R as well. The documentation for the products include an online user's manual that's on the web. We also have links to the laboratory method manuals that are on the web. And Scarlett's been working on a NCSS analyte procedure table and adding links to our directly from the Access database to the procedures in the manuals. That's about 3/4 of the way done. We also have a soil correlation course that we put on, and we have documentation on how to use some of the tools in it. And we have a job aids page for using the Analysis PC tools. So if you need any help with use of the laboratory data, you're welcome to contact your local MO or us at the center. And we're open for questions.
All right, I'll give the folks online a chance to compose their questions using the Q&A pod there in the lower left corner of their Adobe Connect screen. And in the meantime, is there anyone here at the center with us that would like to ask a question? Let me take this up to you so everybody can hear your question.
Henry, do you happen to have any rough idea of how many, you mentioned 64,000 profile description sets in the database? Do you have any rough idea of what the percentage is of that, or how many are PET on PC versions of profile descriptions?
That would be pretty hard to tell. I mean, we do have something that says PET on PC, and since 2005, there are lots of them that are, but that I don't think there's a really good way of telling that for sure.
Okay. Anyone else here in the room with me? All right, we do have some questions online. And the first one is, you know, the group had been adding some university lab data, but is there still some university lab data being entered into the center's lab database?
Yes, we would love to have more university lab data put in. Right now we're working with Alaska, and I know that there's several of the universities that have it out there. We have some universities that have given us PDFs, but we really don't have the manpower to process PDFs. But I know that Iowa we've been putting some in for. As long as people can get it into an Access or an Excel spreadsheet format and give us the methods to go along with those, we accept more university data. Typically, the way it usually works is we encourage people to get the PET-ons in NASIS first. We update the lab. We assign laboratory sample numbers in NASIS. Once we do that, we download an Analysis PC download, which we can use to join the lab data to NASIS. We then import the PET-ons into the NCSS laboratory database, and then the next step is we import the lab data into the NCSS laboratory database. So those are all the steps that are required to get laboratory data into the NCSS Cooperators database.
Henry, you mentioned you're the only one with access to the one table. What happens if you die?
I hope somebody else takes over that table. It's like any other object in NASIS. It can be, we can add users. And that's, which brings up a point as to why, and we even allowed the MOs to have the sites. The reason that we have allowed the MOs to have the sites is because nobody can delete a site if it's linked to a PET-on, and we own the PET-ons. now we have the NCSS lab data table, and as many of you have found out, you can't delete a PET-ON if it's linked to the NCSS lab data table. So each one of these is a safeguard that at least there's going to be one site and one PET-ON for every piece of laboratory data in there that can't be deleted.
We had a question from in the house here.
The negative values and the trace. I think in Access, if I understood it, they are entered as negative. But then when you take them to NASIS, they are transferred into null or zero.
Correct.
So is there any explanation in the database when they get the conversion from negative or traces? I mean, how is that distinction being made? That because when you say negative, maybe just the default, but when you say trace and zero, there is a difference. Trace, yeah, there was something. Zero, there was nothing there measured. Or null. How is that?
We don't have that clearly defined at this point. And luckily for us, most of the values, one thing we have to realize is that the tables in NASIS represent about 84 of the data elements that are in the repository. The way we chose the elements to go into NASIS was we looked at the component table and soil taxonomy. And we chose those values that are most commonly used in the component table and soil taxonomy. Luckily for us, many of those negative values that I'm talking about are oftentimes over in the mineralogy side of things and places where they never actually make it into NASIS. So until we actually start adding those tables for mineralogy and some of the other things, then the negative values won't be as much of an issue to explain away. On the website, there is a download feature, and the download feature specifically explains the fact that there are negative values, zeros, and whatever, and it asks you how you want them represented. It actually displays them as trace and hyphens on the web page, but then it asks you in the download if you want those represented as zeros or nulls in your download.
Henry, there's a comment here. Could you please provide an update on the water retention reports?
I'm going to have to ask Rick to do that. That's why he's online. Rick, are you there?
The comment was, please provide an update on the water retention reports.
Yeah.
And Rick, can you take your phone off mute and talk to us?
Yes, I can.
All right.
Yeah, this is Rick Netzer. I'm not exactly sure what they're looking for, but indeed the soil water retention report was updated from the last edition of the website. And what we did, we added an additional spreadsheet looking like table that identifies the different water retention values that were analyzed by the laboratory. In the past, we only showed two, and that was the third bar less than two, the third bar clod and the 15 bar less than 2 millimeter. But we do take water retention at other tensions such as 1, 2, 5, 1/10, 600ths, and those would not show up. So this new edition of the report actually shows them. So that's
right.
what's different.
And since Rick brought that up about water retention, I also want to mention one other thing is that there are several data analytes or results in our NCSS laboratory database that currently aren't on any reports. They oftentimes are analytes that have been done, we just haven't done a lot of a certain analysis, so they haven't shown up. But in the last few months, Ellis and Steve Monteith and Rich Ferguson have met together to go over that list of analytes, and they've got a proposed list of analytes that we will find some way to either add to the reports if they're not in them, and or also add them to the Access database. Because once again, just like NASIS is a subset of the Access database, the Access database has been a subset of what's on the website. And so there may be some fleshing out of the products where we add a few more of the data elements to the different products.
All right, the next question. Are there plans to provide an ArcGIS feature class with a unique identifier with KSSL lab data?
That could be done. As of now, we haven't done it. Of course, the latitude and longitude decimal degrees is included in all of the products.
And next question, what ongoing applications of the lab data by the research community are you aware of?
That's a rather open-ended question. I know they're using the lab data for, I mean, we get requests from graduate students looking at carbon. We get people looking at the Malick analysis. One of the reasons that we are making our Access database open to the public is because we don't know all the different ways people would like to use our data, and we'd like to make it more generally available to everyone. And I do know there's several people that I've provided the Access databases to, both the morphological and the laboratory data, that we're working on the updates to soil taxonomy and those kind of projects.
All right, last call for questions. Well, hearing none, we're going to conclude our webinar today. I want to thank our presenters, Henry and Rick, and remind everyone that today's webinar has been recorded and will be posted online within the coming week on the National Soil Survey Center YouTube channel, and will be publicly available. Oh, one more comment.
More questions.
Just one thing.